Hey, welcome to the Art of Code. My name is Martijn, and in this video we'll go over the basics of shader programming in Unity. So I have my test scene over here where I just put in a plane and a cube, and the plane has a material over here, plane, and the material has the standard shader that comes with Unity 5. So ever since Unity 5, they came up with a shader that has many different options for many different effects, and for most intents and purposes it really is the best shader to use. So for most intents and purposes I recommend sticking with that, but if you want to make some special effect or something weird that you can't do with the standard shader, or if you're just curious, you can also make your own shader. So let's do that. So what I'm going to do here in my assets folder is I'm going to right click and I'm going to create a shader. So now there's a bunch of different options you can pick here, and for now we're just going to stick with the first one, standard surface shader. Let me call it standard, and let's open this up. Alright, so now let's have a look at the shader code, and by the way, let me just add it over here. So actually over here, this is the name of the shader, and then this is where it will appear inside of the shader drop down menu here. So I go to custom and then standard. So if you wanted to change this, let's say you're making a game, you could have it for instance like this, or if you have many shaders, you could even add subcategories in here. So I could say, okay, my game floors is standard, and now if I save this, now over here my shader appears under my game floors standard. Great. All right, so now the first thing to look at here is this properties block. So it says properties here, and then there is a block between the curly braces over here, and what this is all of the parameters that are exposed inside of the Unity inspector window. So over here it says color, main text, glossiness, metallic, and we have the same thing over here. So color, well, it doesn't say main text here because this is actually the label, right? So the way it goes is this is the variable name that we can use down here, and then this is the label that we can change, right? We can do whatever, and if we change that, then over here it will change to whatever. And then we have our data type that tells Unity what to make over here, whether it's a color or a texture or just a number. And then we have the default value. So let me just take this out. So for a texture, you type 2D over here, and then this is the default value. So if I would take this texture out, then my plane goes white because it says white over here. You could change that. You could say gray as well, or you could make it black as well. And for different effects, you perhaps want to put a different default value. Although if you always put a texture, then the default value doesn't really matter. And then we have glossiness and metallic here, and those are things that we need for our standard shader. So if we change these values over here, then you can see that the surface gets more glossy. And basically over here we're telling Unity, okay, create a slider that goes from 0 to 1 and have a default value of 0.5. Pretty straightforward stuff here. Now let's look inside of here. So inside of the sub shader block, first we have some stuff that tells Unity when to render the object in relation to other objects and how to render it. It's not really important right now. Let's just skip over it, and let's get to the actual shader program, which is between CG program and end CG. And again, there's a bunch of stuff here that tells Unity to use a template off of the standard shader. So what we made is a shader that derives from the standard shader. And that has as an advantage that all of the stuff like glossiness and normal mapping and all of that stuff, or shadows, right? The fact that this can receive a shadow, all of that stuff is built into the standard shader. And so what this does is it tells Unity, okay, use the standard shader template for this. And then let me just move this around, move that over here. Then over here we have all of our variables that we defined over here. They also have to be defined inside of our CG program. And perhaps it's a little bit confusing, but the keywords that you use to tell Unity what type of data type you have are different. So over here it says 2D, but over here it has to say sampler 2D. And the same thing over here, it says range, which is basically a number, and then over here it says half. And so half, there's a few ways to define a number inside of a shader program. You could use it with the half keyword, or with the float keyword, or with the fixed keyword, and even with the int keyword as well. Although int will not get you a real number. It can just get you a natural number, so it can only do 1, 2, 3, 4, 5, but it cannot do 3.5 or something like that. And then these keywords are all used for numbers that can have decimals. And for now, it's not really important to know all the difference. It's just a difference in resolution in how the number is stored. And then over here, so here it says fixed, okay, great, but then it has the number 4 after it, and that is just to indicate that it's actually 4 numbers. So this is actually a vector of 4 numbers, in this case a red, a green, a blue, and an alpha value, which is how colors are typically stored. And then the next thing here is we have a struct that is called input, and that can have a bunch of stuff in it. In this case it only has one thing in it. Structs are used to package stuff together so that we can easily push a whole bunch of stuff into this function here. So if there's only one thing, then you wouldn't really need a struct, but we can add stuff to this, and then it becomes easier to use this. So now let's just get over here, and so this is kind of the meat of the surface shader. And what this shader does is basically a little program that runs for every pixel on the screen, and its job is to fill, again, for every pixel on the screen, to fill these values, to fill albedo, metallic, smoothness, and alpha. And you can also fill the other things if you want, so normal map, height map, occlusion, and whatnot. So that is the whole job of a shader, basically. And we can arrive, or we can fill these values programmatically. So we can kind of screw around with these values. So basically, this is the simplest, or one of the simplest shaders you can have. So basically what it does here is it reads a pixel from a texture, and then it takes that pixel value and it applies it to the albedo of the material, and the albedo is just basically the color. So let's make a simpler shader here. So instead of having something that takes a value out of a texture, we can also just make a constant color. And so I do that by saying float, right? Float is one of these ways to define a number. And then 3, because I'm going to make a vector of 3 numbers, in this case just a red, a green, and a blue. And I'm just going to define a constant color. So I could define red, for instance, like this, 1, 0, 0, and that will make a red screen, or plane. I could also make a green, like that. Okay, and blue would be the last one. And I can also mix these. So I can say, okay, give me full red and full green to make yellow, for instance. All right. So, so that's how these colors work. And now oftentimes you see stuff like multiplying colors, right? Like for instance over here, we're getting a color out of a texture, and then we're multiplying that by this color property. And how does that work? Well, here we can do the same thing. We can multiply a color by another color. So this is yellow, let's say. If I multiply yellow by red, then I just get red. And the reason why is because the way this works is that each individual component gets multiplied for the new color. So the new color is going to be 1 times 1 for the red, 1 times 0 for the green, and 0 times 0 for the blue, which is exactly 1, 0, 0. So that's why this turns red. Similarly, if we want to add 2 colors, the way it works is that it adds the individual components. So if I wanted to make white, I could say, okay, that's yellow plus blue. So that will make a white plane. All right, so that's how the simple operations work on colors. So now let's see what kind of stuff we could do with that. So, well, one very simple thing is like if I have my color C here, I could say, I could invert my colors by saying 1 minus C, right? Because in my C value, I have an R, G, and B that all are between 0 and 1. And by the way, maybe I should put that over here. There's that colors are between 0 and 1. So in other places they're between 0 and 255, for instance, but inside of shaders they're always between 0 and 1. So if I do a 1 minus C, that's basically inverting the color. So now I have an inverted color. Another thing I could do is I could just take one of the channels, one of the color channels, and say, okay, we'll take this as the color. So if I take one of them, I get a black and white image. And the reason why is because inside of HLSL, which is what this language is called, inside of the CG program, it's called HLSL, that has a rule that if you supply one number to something that needs 3 numbers, it's just basically the same as doing this, comma, C dot B. So, and if you have a color for which the R, G, and the B are all the same, you get black and white. All right, so that's one way of getting black and white colors. A better way, in my opinion, would be to take the average of the 3 color channels. So we could do the red channel, the green channel, plus the blue channel, and then divide that by 3 to get the average. And that will just give a different look to the black and white image. All right, what else can we do? Well, we could say, for instance, let's do a mix between the black and white color and the normal colored version. Okay, so whenever you want to do a mix, you use a lerp function, and lerp stands for linear interpolation. And what that does is it's a function that can interpolate between two values based on a third value. So this is my black and white value, this is my original color value, and then I'm going to say mix these together with a certain parameter. And how this parameter works is that if this parameter is 0, it will return the first value. If it is 1, it will return the second value. And if it's anywhere in between, it will return anywhere in between mixed, or those two values mixed. So one cool thing to do would be to expose this as a variable to the user. And one thing I maybe didn't say before is that there is a naming convention that every time you expose something in the properties, you start that variable name with an underscore and then a capital. So that's why this is underscore capital saturation. So let me just take that, copy it, and now I have to also define it over here, right? So now you don't have to put this on its own line. You can just, if it's the same data type, you can just do comma and then enter it over there. And now I can go over here and copy that, and now say saturation, and call this saturation as well, and then let's see what that does. Okay, so now that's it's more saturated now, and you see that if I use my slider, I can go from black and white to colored. So now you can see that like shaders can be handy for stuff. And I don't have to clamp this between 0 and 1. I can make this range higher, and now I can increase my saturation. Okay. And now let's see what else we can do. So this function over here takes as an input a texture, right? The main text, which is this main text, which is that texture. And then it takes a UV coordinate. And let's just have a look at that UV coordinate. So let me just cut that out and make it over here. Load to UV equals this. So this doesn't change anything because I'm just applying it to UV here, and then I'm still using the same UV over here. So that doesn't change anything. But now let's just look at what that UV coordinate actually is. So let me just look at the X component over here of my UV coordinate and see. So now I get something that is black on one side and white on the other side. Or in other words, it is 0 on one side and it is 1 on the other side. Okay, I can also look at my Y component, and then you see it's the same thing but in a different direction. So with these two values, we can tell this text2D function exactly which pixel to fetch from the texture. All right, great. So let's put this back. Actually, no, let's put it over here. And let's make this a little bit more interesting. So let me take this out over here and make another variable called saturation, but without an underscore and without a capital. So saturation equals, and I could say now, for instance, I could make something, I could just take my UV coordinate for my saturation. So now I have a texture that is not saturated over here. In other words, it's black and white, and then it goes to fully saturated over here. And if I want to maybe control that, I could multiply this whole thing by my value, saturation value, and now I have something where I can turn on and off that gradient. Okay. So another thing that we could do is we could say, okay, let's take the sine of uv.x. Okay, and if I just do that, then you will not see something very exciting because my uv.x only goes from 0 to 1, and over that interval the sine doesn't do much. So if I really quickly have a look at what a sine wave looks like, so if I just do the sine of x, then on the interval of 0 to 1 my sine wave only goes up basically, and what I want is I want it to go up, down, up, down. So I have to multiply that value by some larger value to get more of this sine wave. And a sine wave has a makes a full revolution over 2 pi distance. So, and that's like approximation 6.28 or something like that. So if I multiply this by 6.2831, then you can see that now it starts at 0 saturation, and it goes to full saturation, and it goes back to 0 saturation, and then goes to negative saturation. So if we don't want negative saturation, then because this goes to -1 over here, right? So if we don't want it to be negative, then we can just go make it times 0.5 to make it less high, and then add 0.5 to push everything up, and now it goes between 1 and 0. So if we do that, so if I do times 0.5 plus 0.5 and save that, so now you can see it starts at 50% saturation, goes to 100, then goes to 0, then goes back to 50. And you can obviously play around with all of this. What else can we do? Well, we could say we could use the UV coordinate that we use to read a pixel from a texture. We could kind of screw around with that UV coordinate before we read from the texture. So what we could do is we could say uv.y plus equals the sine of uv.x times 2 pi, let's say. So 2a31. And then I want to attenuate that effect. Oh, well, actually, let's have a look at what this looks like. Okay, so that distorts my texture along the sine wave. And if this is too much, then we could just multiply this by some smaller value, smaller than 1. Okay, so, and that will make a smaller distortion. Now, if I wanted to animate this, I could use this variable here that Unity gives to us, underscore time. And underscore time is a vector. It has 4 components. And each component, the time goes a little bit faster, a little bit slower. I like to use the y component, which is the component that changes it by 1 each second. And so let's see what that does if I save this. And basically, this is the time elapsed since you pressed play. So this will not change anything because I didn't press play. But if I press play, then you will see that now I have a nice wavy brick pattern. All right, awesome. So, so that is in a nutshell the surface shader. Okay, so the surface shader has the advantage again that it has already built-in specular highlights. It has built-in the fact that it can get a shadow, that it can even like receive light from a nearby light source, and so on and so forth. But sometimes you want more control and you want to go lower level than this. So let's do that. So let's go over here and make a different shader. So I can go here, go create, and then shader, and now I'm going to make an unlit shader. All right, call it unlit. And now let's look at that one. And the first thing we're going to do is I'm going to change this. So my game /floors /unlit. Save it. Go over here. Let's change my texture, and shader, and you will notice that the shadow, for instance, will disappear. So if I go over here and I go my game floors unlit, so now I have a very simple look. So this is exactly what it says on the box. It's an unlit shaders, meaning that like no lights influence it whatsoever. Of course, we can make it that lights influence it, but we have to make it ourselves. So now let's have a look at how this shader works. So again, we have our properties block at the top. We have our sub shader block. We have our tags over here. We have our CG program. Now our pragmas are a little bit different because we're not deriving from the standard shader. That's one thing. And then we have a bunch of extra stuff here. Also, the whole thing is a little bit longer than the other one. So now the surface shader, like the meat of the surface shader, happens in this void surf, and the job of this function is to fill these output parameters. Now in the unlit shader, we have 2 functions. We have one function over here that is the Vertex Shader, which is a little program that gets called for every vertex on this plane. So let me actually go over here and set it to shaded wireframe so you can see that there's a bunch of vertices inside of here. And then we have the pixel shader over here. And the job of the vertex shader is it gets called on every vertex, and the job of the vertex shader is to the main job is to convert the position of the vertex that is in 3D space, to convert that to a 2D space that is in screen coordinates, so that the pixel can be drawn. So that's what's happening on the first line over here. So on the first line, we're taking the 3D vertex position, and then Unity has a function that does the conversion for us, and then it will return a flattened coordinate, screen coordinate that the pixel shader can use. So that's the main purpose of a vertex shader, and the other purpose is to pass along values. So in this case, it's passing along the UV coordinate over here, and we can actually make this simpler than this. We could even do v.uv just like that. That will not change anything, or change a tiny little bit because of this. So Unity has in there in the inspector for materials, wherever you have a texture, it also has this tiling and offset control over here, which in this case it doesn't do anything because I'm not transforming the UV coordinate properly over here. So if you're not using this, then you don't have to use this transform text. But let me just put it back, and then you'll see that this can move now. All right, so what can we do with the vertex shader? Well, most of the time I don't really use vertex shaders, but what you could do, for instance, you could, let's say, v.vertex.y, which is the up, down. We could say, okay, we'll add to that the sign of v.vertex.x, let's say. Let's see what that does. And now you see we have deformed our surface along a sine wave. Okay, so if I attenuate this a little bit and I do the same trick as I did before with adding the time value, then you could see that, for instance, if you, well, let me make it a bit larger than this. You could see that like this, you could make a flag, or you could make rolling waves, or you could make a splash in the water, or God knows what. So yeah, so for that it could be handy. So that's the vertex shader, and then over here we have the pixel shader, or sometimes it's also called a fragment shader. That's why it's called frag over here. And what the job of the fragment shader is to just return a color. So again, we could just make it simple and say, okay, return a constant color. Something went wrong here. Okay, so over here it will tell me that I should return a float 4 instead of a float 3, because it also requires an alpha value. So, and then of course I need to say float 4. Okay, right. So let me put this back here. So let's just screw around with this a little bit to kind of see, so you can kind of have an idea of what this does. And we also have this fog coordinate here, which is a Unity thing, so that it can apply distance fog. For instance, if you go really far away, it would, and you have fog specified, then the fog would add on top of it. But we don't need it, so we could just get rid of it over here. All right, so let's just finish with something maybe mildly interesting. So we could say, for instance, let's look at our UV. So I can do float 2 UV equals I dot UV minus 0.5. So if you remember, the UV coordinate goes from 0, 0 over here to 1, 1 over there. And so what I'm doing over here is just making it that the 0 is in the middle instead of in the lower left corner. And then I can say, okay, give me the distance from the pixel we're rendering. Like again, a pixel shader gets executed for each and every pixel, right? So the pixel we're currently rendering, we could say, okay, well, give me the distance to the middle of the screen, and you do it like that. And let's see what that does. So let me just return this. Okay, so that gives me the distance to the middle of the plane, right? And really close to the middle, this appears black because my distance is very small, and very small numbers are black, or 0 is black. And then on the outside, it goes not too wide because this distance isn't 1, it's less than 1, but some gray value. And if this plane was bigger, then you would see it would go to white. So let's cut out a little disk. Let's see here, smooth step, let's say 0.1, 0.08, D. If you don't know what I'm doing here with the smooth step, not smooth step, smooth step, then check out this video over here. It explains it in great detail. So let me see here what this does. Okay, so that makes me a little circle. And now let's move that circle around. So what we can do is I can have a circle position. So let me add a position over here, and I'm just gonna call this P, and my P is gonna be a variable that consists of the sine of A, comma, the cosine of A, and now I have to make another variable called A for angle, and then I could use the time dot y, for instance, and now I have to make this a little bit smaller, otherwise you won't be able to see it. So let's see what this does. So that moved my dot, and if you see now I have a dot that circles around the center. So I can play around with that and make it, let's say, a little bit smaller. So it's 7 and 5, let's say, or actually let me just make it 0. No, well, that's wrong. It needed to be 0.07. All right, so now I have a small dot. And now what can I do with the small dot? Well, I could, for instance, make a distortion out of this. So let me just do this. I call it distort, and distort, put that over there. All right, so this shouldn't change anything. It should still be the same. And now, but now I can use that value here to offset a UV coordinate that I'm going to use to read a pixel from a texture. So, again, I just have my unscathed UV coordinate over here. So I just see my brick texture. But if I screw around with this UV coordinate, then I could introduce some sort of distortion, right? So what I could do is, well, let me just look at the distortion again, or what I'm going to build. So let me just stop this here. If I do m times distort, let's say, let me see here if this works. No, it needs to be a float for this. So m times distort dot x, comma, m times distort dot y, comma, 0, comma, 0. Let me see what that gives me. That gives me something invisible because I have to probably make this value larger. So distort times equals 10. Let me see. Okay, so I'm starting to see something here. Times equals 20. Okay, and now, so now I have my distort value there. So let me just go over here. Let's say distort equals distort times 20 times my mask m. And now I take this back over here. I call that col. And now I can use this distortion to add it to my UV coordinate. and that's gonna not affect anywhere this is black. It's not gonna affect it because I'm just gonna add 0 to it. But where this is not black, it's gonna add something to it. So it's gonna distort the UV over there. So if now I do plus distort over here, now you can see that that I have a little bubble that's moving around on my surface. And if this is too much, I can make it less distortion. Okay, so you could see you could make a drop effect like this, or you could make a force field distortion or heat distortion or God knows what. All right, so that was really quickly a introduction to shader programming inside of Unity. Stick around for the next video. We'll make something cool, I'll promise.